Hello students, welcome to the channel. On the ACT in recent administrations, a lot of questions have been asked on repeating decimals. So I thought I'll make a video on this and discuss some of the questions that you may come across. So let's begin. So a repeating decimal is what exactly? It's a decimal of the form where digits after the decimal point show a certain pattern, right? So for example, if I have a decimal of the kind 1.232323 and so on, then that is a repeating decimal and it is represented as 1.23 bar. That bar indicates that this 23 is repeated. If you have something like 7.346346 getting repeated, so then you put a bar over 346. Similarly, if you have a 4-digit stack that gets repeated, you put a bar over that. Now, broadly, there are two questions on the math section that you see from this topic. One is to represent a repeating decimal as a fraction. So how do we do that? And two, to find the nth digit after the decimal point, right? So let's say to find the 325th digit after the decimal point. So how do we do both these kind of questions? Let's discuss. So let's look at representing the repeating decimal as a fraction. So if I have, let's say, x is 1.23 bar. So I know that that means that this is 1.232323, and this goes on ad infinitum. So if I multiply this decimal by 100, then I would get 123.23 bar, because if I bring these two numbers before the decimal by multiplying by 100, then that 23 bar will still stay because that just goes on, right? And this kind of gives me a method of representing x as a fraction, because now if I subtract this from this, I will get 99x is equal to 122, because the 0.23 bar and the 0.23 bar will go away and you're left with 122. So x would become 122 by 99. So the way to represent a repeating decimal as a fraction is to multiply the decimal by a certain power of 10 so that you get the pattern again after the decimal point, right? So for example, let's say I have to solve for x is equal to 7.346 bar, right? This one. So this time my pattern repeats after 3 digits, right? So I would multiply this by 1000x, because that would give me 7346.346 bar. Because just as we saw earlier, 346, 346, 346. So if I bring these 3 digits before the decimal point, then again, I get the same repeating fraction, the same repeating decimal. And now if I subtract the first from the second, I get 999x is 16 minus 7. So that's 9, right? Yeah. And 3 and 7, right? So I get 7339. And the decimal part after the decimal gets cancelled. So x becomes 7339 divided by 999. So this is the standard method of converting a repeating decimal to a fraction. Okay, let's look at the other question type where you have to find the nth digit after the decimal. So let's say I have to find the 325th digit after the decimal for this one, 1.23 bar. Now, if you think about it, this is 1.232323. So it repeats after every 2 digits. So 325th, right? If I look at this, it is 1, 2, 3, 4, 5, 6. So I can see that all the odd number digits are 2 and all the even number digits are 3, right? Because when you have divisibility by 2, you only have even and odd. So here you see that the 325th digit, being an odd digit, will be 2 because all the odd digits are 2. So the 325th digit for this repeating decimal is 2. What about 7.346? Now here we have the digits repeating after every third digit, right? So we can say 7.346, 346, 346, and so on. So here I need to check divisibility by 3, right? Because it is in stacks of 3 that it gets repeated. So if I look at 325, right? 5 plus 2, 7 plus 3, 10, right? So I can see that 324 is completely divisible by 3, right? Because when you add the digits of 324, you get 9, because divisibility by 3 is checked by adding the digits of the number, right? Which means that at 324, these 3-digit stacks will finish. So I'll start a new stack at the 325th digit, and that will be 3 again. So the 325th digit for this repeating decimal would be 3. Okay, let's do the last one, the one with 4. So I have 5.4289. So that's 5.4289, 4289, 4289, and so on, right? So it repeats after every 4th digit. So when I look at 325, I have to check divisibility by 4. Now, divisibility by 4 is always checked with the last 2 digits of a number. And we notice that 24, the number before this, is divisible by 4, right? So I would complete a stack of 4 digits at the 324 mark. So I'll be left with 1, which means the first digit will be the 325th digit. So that will be 4. So the basic idea of solving for the nth digit after the decimal for any repeating decimal is to see the repetition pattern, if it happens after 2 digits, 3 digits, 4 digits, whatever. And then whatever digit after the decimal you have to find, you check the divisibility by that repetition pattern, right? And because, like, for example, as we saw that if it is 5.4289 bar, it would repeat after stacks of 4. So if I check the divisibility of the nth number, the nth digit, n, by 4, I would be able to figure out which digit I reach. So that is what you need to know for repeating decimals. Hope this exercise was useful. This was part of the Basics Explained series, in which we take up the fundamentals of math topics you are likely to see on the SAT and ECT. Let me know if this was useful, and hit like and subscribe to the channel for more such videos. I'll see you guys in a new video soon. Take care. Bye-bye.